Hello everyone. In this video, I want to show you how to use Cython compile code natively into your Python code, where you can take the benefit of C compiled speed like directly into your Python environment. So the first thing that we need to do is that you activate your virtual environment or global environment, whatever you're using, and you have to install CMake and Cython. And since it is already installed in me, it's going to display like this. And once you have installed it, I have basically encountered like a problem, like when I'm trying to compile my Python code. It's because I am on a Windows system and I'm really not sure about the other system like Linux or Mac. So you could just refer if there are any videos out there. So what you can do this in on Windows is that you can basically go to the website where I will be providing you the link below. Uh, you can basically download this, and once you download it, I have already downloaded it, so I'm not going to do it. And you will get after the setup, you will get some more like this. And you will go to the desktop development with C++, where you will be requiring the latest because it is not supported for the older version. And so you'll be requiring this MSVV 143 and Windows 11 SDK and CMake. So I'm not really sure about this too, but you definitely need this. So you can just experiment it out. And once you install it, just try to restart your computer again, and probably it should fix your issue. Now, uh, once you have installed and everything is set up, you basically have a Cython, like which is a .py extension, and you need a setup file where you use your distributed system within this. So now you can do many things. So in this video, I want to keep it very simple. I keep a Numpy array where I want to, sum all the elements within that array, and let's just write it. And I have to see import as well, otherwise it wouldn't work as empty. And there are two ways of writing it. Um, you know, in Python, you can either just write as a plain Python, and also you can use a static type Python, like where you can use C data types like double and as such. And by using static types, it gives you a great performance in comparison to dynamically typed Python code. Even if you just plainly write a Python code within this like Cython, it gives you roughly about a 35% boost in your as in performance. Okay. Now, what we can do is that I wanted to calculate the vector sum, so I'm going to say vec sum, and here there are like various ways to do it. Since you could just say that you're passing a double and you're saying a vect, and I'm just simply going to pass it. So here I'm using a static type, which is like the way you do it in C or C++. So where you mention the data types of this. So this is an array, a dynamic array where you pass the list into it. Since I'm not passing list into it, what I would be doing is that I'll be saying empty array, and I have to specify double, and I would also have to specify the dimension of the array. Since I'm just passing a one dimension, I'm going to specify it as one dimension in here. And uh, I can simply say that s is equals to 0, and for I in range, let's say vec dot shape. Yeah, so vec dot shape, since I'm using NumPy array as an input, when I do this, it's going to give me, basically, I have to do this. Sorry, sorry, what am I doing? Anyway, so this is like apart from this, I'm plainly using Python-like code, and that would still work. Okay, but if you want to greatly boost the performance, it is mostly preferred that use the static typed data types that would give you a drastic performance. And it is always not necessary that by just typing the static types that will boost the speed. So it basically depends. Okay, you have to understand the stance of writing the code. Um, so here, since I'm going to say cdef, and I'm going to say this is double because some float values is going to be double, right? So I'm going to simply specify it as like this. And also, you can mention this I is also a data type, and it have every time it is calling, the Python would basically check if this because when you're passing any a list here, when you're passing it, since in this case it is a range, so it is just going to pass the integers. But in case of Python, what it does is that it's going to check whatever the data types every time it checks the data types. It is just taking too much time to configure. Okay, this is a integer, this is a float, this is a double, this is a string, so you can pass any object into this Python, right? So to avoid that, we can just say cdef, and I would say this is a long. So this is also, C types, C data types, the long, double, float, in, char, and you can just refer the data types. You can just Google it. By just specifying it, it's going to give you a lot of boost because now the compiler knows whatever the data type that is, it doesn't have to do look up every time that to finding what data type it is because it knows it is an long type or int type. So okay, so now this is the vector sum that you have performed here. The next step you need to do is that now you have a pyx file. Now you need to use a setup file, another separate file. There are various ways to do this. One is you can just directly, do within the code. So that will configure, but this is the most recommended way. So I'm going to just go with this method. Um, what you can do is from this utils.core, I need to import the setup from uh, Cython.build import Cythonized. And since I'm using Numpy, I would also have to pass Numpy as well, right? Uh, so you will get to understand a second. Now I have this setup. Now I have external module. So whatever the external modules that I'm using, so in this case I'm using f.pyx, so this which is a Cython file. So I would just simply say this Cythonize the file. And since I'm using an external libraries, I would say that include directories numpy dot get include. So this would like include the numpy into when we are generating a C code that would include the path, so we would not get any errors. So once you have set up this, now what you can do is that you can directly compile it. The way to do is that you're going to say Python and setup build ext in place, and it will. Okay, I'm getting an error. This is because I'm using shape. It's should be size. I think, yeah, and it's not needed to use this one. And when I try to do it, let's see if it's going to build. Okay, it's how build. You could see that our Python have built a C executable, so have about so many lines. Let's see, it have about 9,878 lines. So it's been compiled to this one, .pyd. Now you have C and you have this one. It is not needed once you have this compiled code. If you want to do any sort of debugging and everything, you can just go into this. And if you're just into this, like if you just want to import directly, all you need is this one. You can just simply delete it and it will still work. I'll just show you in a moment like how we can do this. We can either use Torch, like I'm going to use Torch because it's relatively much easier, at least for me. And we're going to say import time. What is this? Import time. And what else we need? Okay, we will just use this one. We need to also import if. We need to import if. And once we import if, since this is the file name if, and I'm going to say print if dot vexsum. At least that is the function that we thought it to be. Let's say a. So let's check. Okay, vexsum is the function. And now what I will do is that I will say torch dot once, and I will say number. I will say number, and I will give the number is equals to 1 e to the power 3. So we have about 10 to the power 3 numbers. And when I try to execute it, and I should probably get error. Yeah, this is because you could see expected NumPy array but got tensor. So how I can fix this is I can not device. I can use data type. I can convert this into the double, and I probably also need to change this to NumPy because that wouldn't work. And when I try to execute again, I should probably get 1000. Yeah. So our code is working. I'm going to delete this one because since it is not necessary, I will just delete it. Maybe I'll just recall it back. And I have also deleted it. And let's check if it's working. So I'm going to try to call it again. And you could see that, okay, what if I'm going to change the variation in my variables? Does it work? Yeah, it is indeed. It is indeed working because we don't need those, files anymore. Once you have this compiled, you can directly import into your Python and you can just execute it. Now, now I just wanted to do one more thing. Like I want to do a little comparison. So I would say start. It goes to time.time. What I will try to do is let me just, and this would be the tensor. And I will just copy this and paste it. And also, I want to create another function. Okay, this is the function that I have. I'm just going to simply copy it and paste it in. I don't need this anymore. So this is Cython, this is the torch, and I'm going to create one more so that I can also print for the Python as well. That's just a pure Python. Now you have this, right? And when I try to execute it, I should probably get like some A f dot like some. Okay, actually I need a plus b because it is expecting a number array, not a dot tensor. You could see that Cython. So for this, it makes not much difference. And let me just increase to magnitude 7, 10 to the power 7, and let's see that. You could see that there is a little time delay in Python. So it's not a significant result because it's not that significant. And if I'm going to increase to the power 8, and you could see that Cython is relatively because even Torch is basically C wrapper to Python, right? And now you start to see the difference. Now it just took about 10 seconds, and uh, you basically see that how much a big of a boost that you got by just using the Cython. By static typing, you're getting a great performance. And uh, let's just lastly say to the 9 and let's compare it. Okay, now we have our results and Python took about 114 seconds. I'm just a little confused why Cython took off about this much. What I'm going to do is that I'm going to run again, but this time I really don't want to wait. I'm going to comment it out and I'm going to calculate the result again. Okay, okay, I don't know why is it happening, but when I just removed it, it worked. Okay, you could see the difference with involved that sometimes the Cython is doing better, sometimes it is just being a turtle. But still, that's a great speed in comparison. Yeah, like it all depends. Like the Cython is it's not as fast as the Python because it is using a Python. It is using some of the Python's calling. So of course there are going to be overhead and delays, and but still you're getting a great improvement within the code. And that's it for today. And thank you for watching. Bye. See ya.